These first two problems I was expecting to be done without a calculator, so running through those really quick. For number one, if I evaluate for f of -5, I'll be substituting in -5 for each time I see x. So I'll read as -3 times -5 squared plus 5 times -5 minus 4. Now I'll just simplify everything down. This comes out to -3 times +25 plus 5 times -5 is -25. I can go ahead and multiply. So that's going to be -75 minus 29, so -104 is what your answer should be for number one. For number two, really important for you to know how to do x minus 3 squared for today's lesson. So you're actually going to do x minus 3 times x minus 3. If you know perfect square trinomials, though, you can actually leap to your answer, but let's say you don't and you're just going to distribute it out. So now I'll distribute x right here to x minus 3, and I'll distribute this -3 to x minus 3 as well. And now I'll distribute those, so x times x is x squared. X times -3 is minus 3x. Now I'll distribute the -3. -3 times x is minus 3x. -3 times -3 is plus 9. So you've got x squared minus 6x plus 9, something that we're actually going to be using today. In today's class, and while this is example 1, we aren't going to do it quite yet, what we're looking at is a new form. This is called standard form. ax squared plus bx plus c. If I were to graph this function, and I wasn't using a graphing calculator, I wouldn't know right off the bat what h and k would be from vertex form. So I don't know my vertex just by looking at this. I actually have to do a little bit of work. And now I'm going to show you some notes on how to figure that out. Alright, so we don't have it in vertex form. This is standard form. First thing that you do, you calculate what's called the axis of symmetry, and you can do that by the formula x equals -b over 2a. Probably something that you've seen before. Now, as far as your vertex goes, the x value will come right from that -b over 2a. Whatever number you get from -b over 2a, that's what your x value of your vertex is going to be. Your y value is going to come from actually plugging that -b over 2a back into the function and seeing what it comes out as. Separate note here, the y-intercept is always the point 0, c. Whatever your c value is, that is your y-intercept. So there is something useful in standard form that you can see right off the bat. Alright, now we're getting right back to graphing this problem I showed just a moment ago. So while it is not in vertex form, I'm going to quickly get what the vertex is by applying the rule x equals -b over 2a. I see that the value of b here is -12, so this is going to be -12 over 2 times the a is 3. So long as it's simplified. If there's anything that funky going on here, like terms that can be combined, something like that, please go ahead and do that before you start this process I just did. Now, -12 is +12. Over 2 times 3 is 6. You want to go ahead and multiply that denominator before you do your division. And 12 divided by 6 is 2. X equals 2. Now what that's going to look like is it's actually going to look like a dashed line at x equals 2. And you can barely see what I just put in here. It is that vertical line, x equals 2. This will be my axis of symmetry. Now, this is only giving me the x value of my vertex. To know the y value of my vertex, what I'm going to do is I'm actually going to take that 2 and I'm going to plug it into the function. So it'll read as 3 times 2 squared minus 12 times 2 plus 6. And I'm going to simplify that down. Just a little bit of basic arithmetic here. And I get -6. So 2, -6, that is my vertex. Now that I've got my vertex, I can look at what my A value is and I can finish graphing out my quadratic. I'll come down here. When I go to the right 1 unit, 1 squared is 1, but I'm multiplying that by 3. So I'm actually going to rise by 3 units when I go to the left or right 1 unit. So I end up at 3, -3, and 1, -3 are other points. I'm going to do this one more time. I'm going to go to the right 2 units this time. 2 squared is 4, but I'm going to multiply that by 3, so I'm actually going to go up by 12 units, which will put me all the way up at 4, 6, and 0, 6. Now, do you recall the Y-intercept? Hopefully you do. Don't really know why I'm asking you on a video that you're watching, but if you recall that the Y-intercept is always your C value, you would see that that's the case here, that it landed at 0, 6. And there's my Y-intercept where it's hitting the Y-axis at. So now I can actually go ahead and make my graph. Try to do a little bit better of a job than that. And there it is. And I've graphed my function. I see what my axis of symmetry is. It's x equals 2. I see a lot of good things. Really quick, going to talk about domain and range. For my domain, I'm going to be looking at the fact that this function will exist for all values on my x-axis. If I go out here to 10, it will have an output. It'll just be really far up here, way off the graph, but it does exist. It does exist for forever along this axis. If I pick the value 1, it existed at -3. Alright, so all x values are present. So my domain is what we call all real numbers. That's a neat little symbol you can use to abbreviate that. For my range is actually going to be not all real numbers because, like for instance, it never gets down to -7. It only goes as far as -6, and then it exists above -6 or equal to it. So for my range, what I'll write for it is that y such that y is greater than or equal to -6. It started down at -6 on my y-axis and exists everywhere above that. It keeps going for forever. So domain all real numbers, range, y is greater than or equal to -6. Just a few extra things I wanted to include. Alright, here's example 2. First thing I'm going to do here is I'm actually just going to quickly rewrite it in ax squared plus bx plus c form, where it was kind of out of order. Now I can actually see what a, b, and c are. And if you need to, you can put a little 1 right here for a, because it is 1x squared. It says find the y-intercept. Now the y-intercept, that's really easy because that's always just your c value. So the y-intercept here is going to occur at 0, 2. Whatever your c value is, that's your y-intercept. The equation of the axis of symmetry, we'll use x equals -b over 2a. So in this case, -4 over 2 times 1. So that's going to be 4 over 2, which is 2. That's my axis of symmetry. And so there's 2 of my answers so far. And wrapping up, what is the x-coordinate of the vertex? That's actually really easy because we just found it. It's 2. It will always be the same as the axis of symmetry. So whatever that is, that tells you what your x-coordinate of your vertex is. And that wraps up problem number 2. If it wanted the whole vertex, we'd have to take that 2 and plug it back into the function to find out the range value. What I'm wanting you to take from this little chart here, it's on page 252 in the Algebra 2 book, is that when the difference between a minimum and a maximum value. The minimum or maximum value is always going to be the y value at the vertex. It is a minimum value when the graph is opening up because the a is positive. That's the a from standard form. It's going to be a maximum value when the a is negative, and you just state what the y coordinate is. So now I'm going to actually run through example 3. There's actually, all of these are based on the same function. Determine whether it has a maximum or minimum value. Because the a value is negative, it's negative 1 here, it's going to have a maximum value. And that's because the graph would actually be going downward because the a value is negative. It's been reflected in the x-axis. Moving on to part B. We're going to state the maximum or minimum value of the function. That requires a little bit of work. We're going to have to do negative b over 2a really quick. In this case, that will be negative 2 over 2 times negative 1. That ends up being negative 2 over negative 2, so that's 1. That would be the x value at the vertex. So 1 comma what? Because this y value at the vertex, that is your maximum value. It's always your y value is your maximum value. Excuse me. So let's go ahead and plug that in. F of 1 would equal negative 1 squared plus 2 times 1 plus 3. And that comes out to negative 1 squared is 1. Plus 2 times 1 is 2. Negative 1 plus 2 plus 3, it comes out to 4. So for my answer for part B, my maximum value is 4. That's my max value. Alright, moving on to part C. This is actually going to be really easy. The domain for any quadratic function is going to be all real numbers. Or you could use an abbreviation of this symbol right there, the set of all real numbers. For your range, what you're going to see is that's not all real numbers. We just said, hey, this function has a maximum value of 4. That's the highest it can be. It has to be less than or equal to 4. So for my range, it is f of x, not y, because the problem said f of x, such that f of x must be less than or equal to 4. This is called set notation, and that's what we're going to work with a little bit in here. So on this problem, what's going to happen is we're actually going to figure out how much this owner of this shop should charge for the coffee mugs in order to maximize the profit, or income, I should say. So I'm going to say X is the number of 50-cent increases I'm going to consider Y to be my income, or the owner's income, I should say. What's going to happen then? Y, the income, is always equal to the price times the quantity sold. And we can calculate both those. Well, we can represent them with expressions based on X. Right now, the price is $6, but he's considering increasing that by 50 cents a few times. So what we'll do is we'll say right now his price is $6, but he's going to add 50 cents to that each time he increases the price, X. Alright, now what about quantity? Well, as he charges more, there's going to be less demand for it. So the quantity is going to be 200 is how many he's selling right now. But that's going to go down by 10 mugs each time he increases the price. And there's my setup. What I'm going to do now is I'm going to distribute this out, get it in standard form. So I'm going to distribute the 6 to the 200, that's 1200. Distribute the 6 to the 10x, that's minus 60x. Distribute the 0.5x to 200, that's plus 100x. And 0.5x times negative 10x is minus 5x squared. And so in standard form, it's going to be negative 5x squared plus 40x plus 1200. And what you'll see here is that now you've got a function that you can actually calculate the maximum for. And what we're really interested in is the value of x that gives you that maximum, because that will tell you what the owner needs to charge. So, calculate the axis of symmetry, negative b over 2a. That'll be a x value at the vertex, which in this case will be negative 40 over 2 times negative 5. That is negative 40 over negative 10, and that comes out to 4. Now, he should not be charging $4 per mug. Remember, X was the number of times he raises the price by 50 cents. So he's going to raise the price by 50 cents 4 times to get the maximum income. So raising it 50 cents 4 times, well, that's $2 added. $2 added to $6, he should be charging $8 a mug. So he should charge $8. If you want to know that actual income that the owner would now have, you just plug the x equals 4 into your function, and the value that pops out would be the income that the owner could now anticipate. And we're done with the problem.